Imagine you're a detective trying to solve a high-stakes crime, but the suspect's mind is a literal black box. You can see every action they take, every word they say, but you have absolutely no idea why they're doing it. This isn't just a scene from a sci-fi thriller. It's the daily reality for security teams working with modern artificial intelligence. Today, we're unpacking the black box problem. When a security team audits traditional software, they have powerful options. Source code is readable. It has logic and structure. Even compiled binaries can be disassembled and reasoned about step by step. But a trained AI model's weights are different. They aren't logic. They're billions of floating point numbers, the cumulative result of a massive training process. And they carry no human-readable record of how they were shaped. Think about that for a second. You cannot simply open a model and find the specific decision path that makes it behave a certain way. There's no if-then statement to find. It's a mathematical labyrinth where the data influences billions of parameters in ways we can't manually trace. This is why we call it a black box in the truest sense of the word. We see the output, but the internal reasoning is opaque. So, how do we trust these systems? Traditionally, we test their behavior. We run thousands of inputs, benchmark them against known tasks, and probe them with adversarial prompts, a process called red teaming. While these methods are incredibly valuable, they are fundamentally just sampling, not auditing. A test can tell you how the model behaved on the inputs you tried, but it can't tell you what it will do on inputs you haven't thought of yet. Trusting a model fundamentally means trusting the process that produced it. To bridge this transparency gap, Google researchers introduced a revolutionary concept in 2019, the model card. Since then, it has become the industry standard for transparency. Think of it as a structured resume for an AI model that travels everywhere the model goes, providing the context that the numbers alone cannot. The easiest way to understand a model card is to think of it like a nutritional label on a box of cereal. You can't see the individual grains or vitamins inside the box just by looking at it, but the label tells you exactly what went into the product, and, more importantly, what you should watch out for. It's the essential documentation that transforms a mystery box into a known quantity. A well-formed model card should give you the answers you can't get from the weights themselves. First, it covers the training data, what sources were used, how they were filtered, and any known biases in that data. Second, it defines the intended use. It explicitly states what the model was designed for, and, just as importantly, what it wasn't designed to do. This prevents dangerous misuse in critical scenarios. Next, it provides evaluation results, actual performance metrics across different conditions and demographics. Finally, it highlights known limitations. This is the warning section. It tells you exactly where the model is known to underperform or behave unexpectedly. Without this, security teams are essentially flying blind, hoping the model doesn't hit a trap they haven't sampled yet. But here's where the ideal meets a harsh reality. Have you ever checked a food label and realized those chicken slices are only 49% chicken? In the AI world, model cards can be just as problematic. They are frequently incomplete, vague, or in some cases, completely absent. Unlike food labels, there's currently no regulatory requirement to produce one. It's voluntary, and for many, the incentive to be thorough is weak. The Data Provenance Initiative recently audited over 1,800 datasets and found massive documentation gaps throughout the entire AI supply chain. Model cards sit at the end of this under-documented pipeline. If the foundation is missing data, the card at the end can't be trusted. When a model card is sparse or missing, it isn't just an inconvenience. From a security standpoint, it's a massive warning sign. It means the organization either didn't evaluate the model thoroughly enough, or they chose not to share what they found. Either way, the downstream user is left at risk. As we build the future of AI, transparency cannot be optional. We must demand detailed model cards, audit the supply chain of our giants, and never settle for a black box without its label. Truth in data is the only way to build secure AI. The black box problem is a challenge, but with the right documentation and a demand for transparency, we can secure the revolution. Thanks for joining this deep dive into the nutritional labels of AI. Make sure to audit your models, stay curious, and I'll see you in the next chapter of our AI series.